Looking at number 6 from the 2013 BC exam, we have a function that has derivatives of all orders at x equals 0. P sub n is the nth degree Taylor polynomial and about 0, so otherwise known as the Maclaurin. Let's see. So f of 0 is -4, and the first degree Taylor polynomial at 1/2 is -3. They want you to show that f prime of 0 is 2. Well, my first degree Taylor polynomial in terms of x would be f of 0 plus f prime of 0 over 1 factorial times x minus 0 to the first, which we could then turn that into, because I know f of 0 is -4, so -4 plus f prime of 0 times x. And then they tell you that if I plug 1/2 into this, I would have -4 plus 1/2 f prime of 0. They tell you that that answer should be -3. And so we're going to solve for f prime of 0, and we should get 2. So we have half f prime of 0, add 4 to both sides is 1, multiply both sides by 2, and you get f prime of 0 equals 2, and we are done. So that was a proof. That was kind of nice. They gave you the answer. We just had to show what the answer was. They could have made it a smidgen more difficult by asking you to find f prime of 0 instead of giving you the answer. So good for them. All right, so number B. It is known that f prime, double prime of 0 is -2/3, f triple prime is 1/3. Find the third degree Taylor polynomial. This one won't be too bad because we already have the first two terms. So my third degree Taylor polynomial is going to be -4 plus f prime times x. That's just copying these two and replacing the f prime of 0 with 2. Then plus f double prime is -2/3 over 2 factorial times x squared plus f triple prime is 1/3 over 3 factorial times x cubed. And we are done. That is it. And again, we're just using the general formula, the nth derivative at, not x, the terms for any Taylor polynomial, the nth derivative at the center of your series over n factorial times x minus c to the n power. So that's what I'm using in both parts A and B. My pen quit writing. Oh, there he goes. Okay. All right, so there's A and B, very quick, two very quick problems. And then part C, and I think this is the last part. It is. So part C, the function h has a first derivative given by h prime is f of 2x. It is known that h of 0 is 7. Find the third degree Taylor polynomial for h. So I'm going to do the exact same thing. I'm going to use the nth derivative at 0 over n factorial times x to the n power. And I need to get to the third degree. So I'm going to need h of 0, which they tell you is 7. H prime of 0, which h prime is f of 2x. That's going to be f of 0. And f of 0, we're going to have to go back and forth between screens here. F of 0 is -4. H double prime of 0, we're going to need to work out two more derivatives here. So h double prime of x is going to be f prime of 2x times 2. H triple prime of x will be the derivative of that, which will be f double prime of 2x times 4. So h double prime of 0 is going to be 2 f prime of 0. H triple prime of 0 is going to be 4 f double prime of 0. And going back, f prime of 0 was 2. That was our part A work. So 2 times 2 is 4. F double prime of 0, whoops, wrong way. F double prime of 0 was -2/3. And so 4 times -2/3 is -8/3. And now I can just roll all of this into a Taylor polynomial. So that means h of x is going to be approximately, because a Taylor polynomial is an approximation for the original function, 7 minus 4x plus 4 over 2 factorial x squared minus 8/3 over 3 factorial x cubed, and we are done. That is it. This was a very quick, very nice Taylor series question. I imagine this one was very high scoring. The one thing I want to point out is your use of equal symbols and approximate symbols. Notice I used an approximation symbol here because I had a third degree Taylor polynomial that approximates h. However, in parts A and B, you may have noticed, maybe you didn't, probably not, that I used equal symbols for P1 and P3. And the reason I used equals is because I didn't say f of x is this. They defined P3 to be the third degree Taylor polynomial. This is the third degree Taylor polynomial. So this is P3 of x. Now you could, if you wanted, say this is approximately f of x, but we don't need to do that because they defined them as p sub 1 and p sub 3. So that's why I used the equals symbols on parts A and B, yet I used the approximate symbol in part C.